Openssl 3.0 was released recently. Current version is 1.1.1, so it is a major release. Since it is a new release, there aren't any packages currently available for it, but the source code is freely available. And we're going to go through the steps of downloading and installing the source code. Now, to install the source code, I'm going to use an almalinux system here, and I'm also going to use a Debian system. To get the source code installed, you have to get the development tools on both of the machines. So for these Fedora-based systems like almalinux, the command is dnf group install development tools, and the development tools has to be in quotes. And for the Debian-based system, the command is apt install build essential. Now, I'm actually root on these boxes, so I don't have to use sudo. So let me take that out. So you run apt install, it does its thing, and it goes down, installs all the compilers that it needs and everything. Same thing on the almalinux box. You do the install. It shows you all the packages it's going to download and install. You hit yes and let that go ahead and run. And I will come back here once this is complete. That took about 3 minutes on both machines to get all the development tools installed. And there are some other packages that are needed for the installation. These are actually Perl modules that are needed to do the install. And if you want to run the make test later on, you have to have this Perl module. And I found that there were no Debian packages for this module and this one. And then for the Fedora/Red Hat, I found there were no modules, well, no packages available for this one. So we're going to have to manually install those missing modules using cpan, which comes with Perl. So we're going to go first to the Alma system, and we're going to install the packages that are needed. Those are the Perl modules that were available. And I noticed that the almalinux/Fedora installation of the development tools didn't install cpan by default. So you have to add cpan there. And we're going to go ahead and let that run. Okay, I'm not sudo on this box, so I don't have to run sudo. I'm already root. So it tells me it's going to install that. Now it's installing the packages that I requested, plus it's installing any dependencies. So these are all the dependencies. And I tell it yes to go ahead and install. Now the package names are different on Debian, so I will copy those in. All right, here we are for Debian. The Perl modules are listed there. And I noticed that the Debian developer tools don't include Git, and the VI editor, the basic text editor, is not included by default. So I'm going to add those in. And I've got sudo in here again. Take that sudo out. And it's going to install all the packages I asked for, plus the dependencies. I'll type Y for yes. And it will go through and install those additional packages. Now remember, we had some packages that were not available. So this test more needs to be installed manually with cpan. So I will copy that and I will run cpan. The first time you run it, it wants to configure itself. So I'll just say yes. And the command is install. And then the name of the module, which is test : more. It goes through, it updates the current version of cpan, and then it goes through and it downloads that module that I requested and it installs it. Now down below on the Debian system, it was missing two packages, the IPC command and the pod HTML. So I have to do the same thing with cpan. I have to install those manually. And this one's finished up here, so I can exit. And then come back down to the Debian system. Where is it? Oh, there it is. Okay, under cpan again. Again, first time install, it wants to configure itself. And I would install IPC-cmd. And it also finds a new version of cpan. So what it tells me here is that it can't find the module listed that way. So I have to find a module that's closely related to it that does the same thing. And they tell you the command to run here, which is the I with the module that you want inside the 2 slashes there. So I'm going to run that command. And look for an IPC-cmd, and I see one here. And that looks like the closest thing to it. Where those run down here, but it looks like it's an older version, a 0.22. So I'm going to go with the 1.04 version. Going to copy that. I'm going to copy the whole thing. I'm going to tell it to install. And it's going to go in and download and install that module. And the other missing module was the pod-html. And we do the same thing with that. We do the install, paste it in, use pod. And we get that message that it can't find pod-html. It says try this command, so we try that command. And again, we look for a module that's similar. And I tried this HTML easy, and that one seemed to work. I'm assuming it's just a version of the pod HTML. So I will copy that and I will install. And that will go through and install all the modules that I need. Once we go to looking at the source code, there's a README file there that lists some of the modules that are required, but it does not list all the modules. I kind of figured out which ones are needed by running the compile and then looking for errors and finding the missing modules. Now that took a few minutes to finish. So now we've got all the development tools and all the Perl modules that we need to actually start the installation. So what we want to do, there's an announcement here from back in September that Openssl was released. It says, please download it from here. And there's a link there, which goes out to the Openssl source directory. And I want to pull from the Git repository where the master sources are located. And it tells you to run this command, git clone. That's going to copy the source code down to your local system. And I'm going to make sure I'm in the root directory there. And the command is the same for git. So that is actually going to download the Openssl source code and put it on the system. So all it's doing is going to their GitHub site, putting a local copy of the source code here on both of the boxes. We're going to use this Alma box, so I'm going to make this window just a little bit larger. You see, it created a directory called Openssl. I'm going to get rid of this to clear things up here. In the Openssl directory, there are a bunch of files here. We want to look at the install.md file. They're just text files, even though they end with md. It gives you information, tells you what you need. Perl 5. It says core modules, and you want to read this notes.perl for any additional modules. Tells you need the C compiler. We installed the C compiler on both earlier. We installed that. We installed that. Gives you a little information about commands. And basically, you're going to run a /configure. And that configure has a capital C. You're going to run a make and a make test. And if that's all successful, you run a make install. So we're going to look at the notes that it had for Perl. And it tells you about, it says that they rely quite a bit on Perl. That's why all those additional modules are needed. So when you go down here, it talks about required Perl modules. It tells you the text template is required, and the test more is you want to run the make test. And it tells you how to find those, and it also tells you how to install cpan and install templates, just like we did before. Now, I did a little reading on this configure, and I found that if you're going to install it in the non-default folder, which is normally /opt, you have to specify the prefix and also tell it what directory it's going to be installed in. And the last option here is to enable FIPS. Let me copy that, get out of here. Okay, back on our downloads page. Openssl supports FIPS, which is some type of government standard for cryptographic modules. So if you're using Openssl to generate certificates, or you have an application that's written and compiled with the Openssl modules, they are written to support this FIPS 140-2 standard. And I believe over here it says they've submitted the request for approval, but it hadn't been approved yet. So they're still rating the FIPS 140-2 approval. Here it is, submitted for validation right there. It says they've submitted it there. That was back in September. There is a FIPS 140-3 standard that was released recently also, but they don't currently have anything that's approved for the -3 yet. And when you go in and you're getting ready to do the configure, that's not what I want. I want this whole configure command. Okay, so it runs the configure command that I pasted in. And when you add the enable FIPS option, there's no dash in front of it. There's no dash in front of it. It's just enable -FIPS. And I will do the same thing on the Linux box, not the Linux, the Debian box. So I'll /configure, tell it where the prefix, tell it where the Openssl directory is, and I'll hit enter. That's because I'm not in the Openssl folder. So when I do that command again, it'll go through and it'll run the configuration script. Okay, so we've run the configuration script on both. The first thing we're going to do is type in the make command. And let's see how long it takes on both of these. I'm running time in front of make to tell me how long this command is going to take. And I'm going to do the same thing down here. Now these boxes are actually 2 containers running on an almalinux box. Let me get back on it. Come on. All right, I got two-factor enabled on there. I got to type my code in. Watch my previous video on two-factor authentication. So this is actually almalinux virtual machine running Podman. Under Podman, I've got one container running almalinux and one container running Debian. I do that so I can install stuff, test it, and just wipe it all and not have to worry about it. So you can see it's doing about 84 to 85% on the processor during the compile. And we're going to let both of those go ahead and finish compiling, and we'll come back after that. The make is finished on both systems. Took about 4 minutes and 3 seconds on Alma, 4 minutes and 1 second on the Debian box. So the next command to run here, which would be make test, I'm going to time that also. Now you don't have to use the time command. I just use it to see the different compile times between the two different systems. Now, if you didn't have that module installed, what's it called? If you didn't have the test : more module installed, when you run this make test, it would fail with an error message. Even if the previous make command was successful, the test more module is needed to run the make tests. And we're back from an exciting 5 minutes and 39 seconds and 5 minutes and 25 seconds running the make tests. And you see that it passed on both systems. All right, so now that's all done, we can actually do the install. And we'll run the make install. Now the make install looks at the command line options that you use for the configure. And we told it to put it in user local Openssl 3.0. Again, if you don't specify where you want to install it, it installs in the default location. That default is normally /opt, and sometimes it's user local. I was going to stop recording, but it looks neat on the OBS window, so I'll let it run and keep recording. I'll probably just slow it down. All right, the make install has finished, and it gets down to the bottom and it says installing the FIPS module. You want to make note that it installed it there. Same with the Debian box. It installed the FIPS module and it installed it there. So let's use the Alma box for example. So if I go to the folder where I installed this, you can see it created some directories. The binaries are in bin. The libraries are in lib64. There's the Openssl configuration file. So if I switch over into that bin directory, into ls, I can see I have a binary there called Openssl. Now it isn't ready yet. If I try to run that with the full path or with the // notation, you get an error that it can't find the shared object file. It's looking for some libraries. It's looking for the libraries that are in this folder. So what did it say up there? It libssl.so.3, which is here. And that's because the system does not know about these libraries since you are compiling them by hand. So you have to let the system know how to get to these library files. And this is the path that they're in. So I'm going to copy that. You go to Etsy. And there's a file there called ld.so.conf. And there's a single line in there that says include any files that end with conf from this directory. So we're going to go into that directory. You're already in Etsy, so let's go to ld.so.conf.d. And there's only one file in there. And the format is just the folder that has the libraries that you want to add. So we're going to create a file, Openssl 3.0.conf. It has to end in .conf. And inside of that, we're going to paste in the folder that has the library files for this Openssl 3 that we just compiled, which is here. Right quit, which saves it. Now it's the configuration file is there. You can reboot it and it'll pick up the change, or you can just type ldconfig and it goes back through and reads all the new files and applies them. So when I run ldconfig and I go back and to try to run that command again, I have the full path in here somewhere. Yeah, there's the full path to it. So now when I run it, it runs like normal. And I tell it I want the version. It tells me it's reading a 3.10-dev. So it tells me about the compilers, the platform, stuff like that. So basically it's ready to go. And you do the same thing on the Debian system. You go to Etsy, ld.so.conf.d. They've got a few more files, but you're doing the same thing. You're creating a file for Openssl. Name doesn't matter as long as it ends in conf. Pasting in that directory. Saving it, running ldconfig after you make the save or reboot the system. You run user local. Oh, it's in bin. You get the same results. So you can now start using the newer version of Openssl, and you can generate your certificates and CSRs and all that stuff the same way you do with any version of Openssl. And if you've got other programs that you have to compile and you need the development files for Openssl 3, you have them here. Those are the files that you downloaded. Now, I just happen to put them in root, but you can put them anywhere you want. Yeah. So now you've got all the downloaded development code, and you can compile your other programs and use the development files from the newer Openssl. The new version of Openssl is not that hard to compile. There's just a few modules that are not listed in the documentation that you have to add. Once you add those in, you have to tell your system about the new libraries that you just compiled. Thanks for watching. Go ahead and like and hit subscribe